Okay, well, why don't we get started? I want to thank you all for coming out today. My name is Paul Sabin, and I teach in the history department and help run the Yale Environmental Humanities Initiative. And I am delighted to welcome Rachel Morello Frosch to the School of Forestry and Environmental Studies, and I want to thank Karen Cito and the school for hosting Rachel. So Rachel Morello Frosch is a professor in the Department of Environmental Science, Policy and Management, or ESPM, and also the School of Public Health at UC Berkeley. And she received her master's and doctoral training in epidemiology, biostatistics, and environmental health sciences at UC Berkeley. And her research examines race and class determinants of environmental health disparities among diverse communities in the United States, with a focus on environmental chemicals, climate change, drinking water, and linkages between environmental sustainability and social equity. So I actually met Rachel when I was a graduate student at UC Berkeley back in 1998, and it was part of the planning process for a national organization that we ended up starting called the Environmental Leadership Program, and Rachel had been recommended to me by some people at the Switzer Foundation. Some of you might know the Switzer Fellowship with Rachel had been a Switzer Fellow, and she's actually now on the board of the Switzer Foundation. And the idea behind our initiative, we were both graduate students or just finishing our graduate program, and the idea was to try to bring academics and practitioners together and to get them to learn from each other so that academics could try to become more oriented to and connected to people working outside of the university in community-based organizations, environmental organizations, or government. And for practitioners to connect with some of the ideas and the research that was going on within the universities. So it was really for academics like ourselves, the goal was to try to develop as top-notch scholars while also becoming engaged public intellectuals and collaborators. And I mention that just because I think that Rachel, as much as anyone I know really, has succeeded in this challenging balancing act in both doing her research, but much of it has been done in collaboration with regulatory scientists and a variety of community partners. And through that process, over many years, Rachel has been developing these scientifically valid and transparent tools for assessing the cumulative impacts of environmental and social stressors, all with the goal of trying to improve regulatory decision-making and also advance environmental justice. So she's applying these methods in a range of areas related to public health and also the implementation of climate change policies in California, so a variety of different sectors. And has written widely about this in her scientific articles. So Rachel is the co-author of Contested Illness, in addition to all of her many articles, Contested Illness, Citizen Science, and Health and Social Movements. Her research has been supported by the NSF, the California EPA, the California Breast Cancer Research Program, the NI Environmental Health Sciences, that was NIEH? I'm in history. National Institute of Environmental Health Sciences, and also a variety of private foundations. And Rachel also is a civic leader as well, and serves on the board of Grist magazine, which some of you may read Grist as an environmental news source. Anyway, so I won't take up any more of your time. I'm delighted to welcome Rachel to Yale.
Thanks, Paul. Thanks, everyone, for coming out and for letting me have such great New England weather. I haven't been out here in a while. So I'm going to talk about this question about the connection between environmental justice, social equity, and public health. And I'm going to kind of talk about the trajectory of the work from my lab in terms of how we've sought to answer this question and some of the methodological challenges of doing so, and hopefully end with practical applications of how we translate the results of our work, even when causation isn't necessarily firmly established, but there's a weight of evidence out there to begin to design, thinking about how do you develop tools to improve policy making to advance EJ goals, even as scientists still sort out the details, if you will. And if you have questions, please interrupt me. I'd much rather have a conversation. I'm going to try and leave time so that we can have a conversation at the end. Okay, So I want to talk a little bit about the ways in which environmental justice has permeated environmental health research and reoriented scientific thinking in this field. A little bit of an introduction on what I like to call the political economy of riskscapes, and how the science of cumulative impacts has emerged in my field, what it is and what some of the scientific results suggest. So I'll highlight that. And then what are some of the implications in terms of what we know for understanding social determinants of environmental health disparities, and then applications of this work in California. So I'd like to start out my talk by looking at projections for changing demographics in the country. This is looking at from 1970 until 2050. And this, in many ways, is epitomizing. California is already, here, because California and the areas of the Southwest and the western part of the country tend to be a bellwether for demographic change for the rest of the country. And I would argue that these shifting demographics and the constituencies and the politics around it has shifted the conversation that we've been having about environmental policy making to the point where environmental justice has become an important aspect of regulatory decision making and in environmental epidemiology and environmental health science. And one of the reasons why this has changed is because activism around issues of environmental equity and environmental justice has also shifted funding streams at the federal level. Okay, so most notably, when the National Institutes of Environmental Health Sciences had its first African American director, that agency started creating funding incentives for scientists like myself to do more collaborative science in working with the impacted communities that we were studying. So, for example, if you wanted to get a grant to create the center of this, that, and the other thing to study an environmental health issue, you had to have great science and great scientific projects, but you also had to have a community engagement core where you had some element of a community partner, and at minimum of research translation, and even better if you were actually engaging communities in the development of your scientific methods, data collection, interpretation, and dissemination activities. So, for example, the Children's Health Centers, the Superfund Research Program, other major funding initiatives require a community engagement core, and these have been going on now for a couple decades and more. Some of those relationships between scientists and communities have been sustained for a very long period of time, and I think those relationships have really shifted how scientists think and understand disease causation in the field of environmental health. So what I mean by that is that both scientists and the regulatory community have been pushed by environmental justice advocates to do our science better in two elements in terms of addressing what they like to call cumulative impacts, and which is now regulatory lexicon in many regulatory agencies like Cal EPA, US EPA, not so much anymore, but it was there before. So the first aspect is really scientifically thinking about how do we consider social inequality and links to environmental degradation when we're trying to understand health disparities. How do we better understand diseases that we know are caused by social factors, which influence behaviors and so-called lifestyle, but also environmental elements, and really get at the fact that people are not exposed to one contaminant at a time, not one facility at a time, but multiple hazards in the different environments in which we live, work, and play, as EJ advocates like to say. The second element of cumulative impacts is getting at this question of vulnerability, okay? That communities of color and the poor, for example, are chronically exposed to social stressors such as poverty, food insecurity, chronic experiences with discrimination, and underlying chronic health conditions, whether it's high incidence of cardiovascular disease, diabetes, which can make these communities inherently more susceptible to the toxic effects of environmental contaminant exposures, for example. Lead is a very good example. New Haven, lead's a big problem. So we know for a fact there's been huge improvements in decreasing lead exposures in the population in the U.S. due to regulations. However, African American kids are still disproportionately have higher lead levels than other kids, particularly poor kids. And the neurological effects are stronger among kids who are malnourished, and there's a biological mechanism for that because there's the malnourishment, lack of nutrients, increases the absorption rates of lead in the nervous system. Okay, so I'd like to use this schematic so that we can kind of understand this notion of political economy of riskscapes. I'm in the field of public health. We talk about the risks of this, that, and the other thing. And environmental health, we do the same thing. But I like to, if we're really going to think about social determinants, we need to, as best as we can, try and take into account, for example, social context, which gets into issues of social inequality, racial residential segregation, and then policies that might be discriminatory against certain marginalized groups. This plays out demographically. Certain racial and ethnic groups of lower levels of educational attainment, immigration status, wealth, and geography all influence the ways in which these policies can play out and disproportionately impact certain groups. This leads to, on that box on the far left, disparities in exposures to environmental hazards, and these are just a few examples: occupations, living in places with poor air quality, high traffic density, water contamination. Then in this middle box, we have what I like to call social vulnerability factors or extrinsic factors. These are things related to poverty, food insecurity, exposures to psychosocial stressors, healthcare access, experiences with racism, and gender roles. These are all modifiable. These are not biological, okay? These are things that could be modified by policy and other kinds of interventions. And then here, we have biological susceptibility factor, what I call intrinsic factors. These are things related to our bodies, our age, underlying disease conditions that we may have, malnutrition, genetics, and sex. So these factors can create underlying susceptibilities related to the toxic effects of environmental hazard exposures. So these things can come together and interact or have additive effects that can partially explain the origins and persistence of health disparities for a variety of diseases, particularly chronic diseases, and of course, mortality. So there's been a lot of folks that have written about this in terms of thinking about this as a framework for improving our science and environmental health. I like to show these pictures because these are kind of what environmental justice advocates think about when they think about cumulative impacts. This is in Richmond, California, which is about a 15-minute drive from UC Berkeley. It is home of the largest oil refinery west of the Mississippi. This refinery is over 100 years old, and we've done some work here. I'm not going to talk about it today, but household exposure studies here in this community of Liberty and Atchison villages, which is right along the fence line of this community. But in addition to the refinery, you have other sources of hazards: a rail yard, two interstate freeways, a marine terminal, and different kinds of chemical industries. And then this is anyone here from Southern California? It's LA area. This is the, there you go, yeah. So this is the 710 freeway. This connects the ports of LA and Long Beach to what is known as the Inland Empire in San Bernardino County. San Bernardino County has some of the worst air quality in the country, probably next to California's Central Valley. But this freeway, most of the goods that we buy at places like Target and Walmart come through the ports of LA and Long Beach. This is one of the largest ports in the country. And so there has been a lot of talk about widening this freeway, and the truck traffic has a disproportionate impact on the residents that are living here. And so EJ advocates put up that billboard. Okay, so I've given you kind of a schematic for understanding this notion of cumulative impacts and trying to give you some history in how environmental justice advocates and these community scientific partnerships have really pushed science in the direction of trying to understand this. And we're really grappling with it because it's a very straightforward question, but from a methodological point of view, a perennial challenge how best to study. And it requires multidisciplinary strategies and different data sources to really get at what's going on. So those of us who do epidemiology, often the gold standard is that you collect primary data. For example, I have, you start a cohort. I have a cohort in San Francisco where we've been recruiting pregnant women for the last 4.5 years, and we follow them, and now we're following their kids, and we're looking at their exposures to chemicals in utero, and their exposures to stressors, and now we're just waiting to see, who gets sick and who doesn't, and that takes years. And it's very hard to collect that data, and you're often limited by your sample size in terms of the kinds of questions that you can effectively ask of your data, if you will. So while these methods are excellent and I think they're incredibly important, sometimes that sort of methodological strategy is somewhat limited because of a lack of statistical power. It's often a very small geographic scope, okay, so it's very place-bound in a particular geographic area. The time and resources required to do those studies can be enormous. And there is a need for what I like to call data judo, in that there is very good data already out there that can enable us to answer some of the questions that you can't answer from those kinds of primary data sources that is often done with traditional epidemiological studies. So I'm also a big proponent of how do you leverage these large secondary administrative data sets to answer some of these broad-based questions about environmental justice that primary data kind of doesn't let you do. All the while knowing that primary data can still be very important for elucidating the relative contributions of environmental social stressors at the individual level. And so you don't want to lose sight of that either. And I would say that environmental justice analysis requires both approaches. Today I'm going to talk mostly about the secondary data strategies that we've done for exposure assessment, and to look at linkages between social inequality and environmental justice and environmental inequalities, and also degradation of environmental indicators in general. Okay, so the first assertion is around cumulative impacts is disparities in exposures to environmental hazards, and that these kind of come across racial and socioeconomic lines, and they are relevant for trying to assess potential health risks. And the second element of that is thinking about the ways in which measures of social inequality potentially undermine environmental quality for everyone. So it's not just who bears the burden, but the extent to which social inequality is problematic for all groups. And we did kind of a review article on this question more broadly that we published in the annual reviews of public health. But I want to show you some examples of studies that we have done. So I, as a graduate student, got very interested in the role of racial residential segregation in looking at air quality indicators. I started looking a lot about air quality. And so this is a map looking at racial residential segregation in a little over 309 metropolitan statistical areas of the United States. And this is a measure known as the multi-group dissimilarity index. It's actually quite commonly used in the social science literature. And in a nutshell, the beauty of this measure is that it allows you to look at segregation across multiple groups, so it's not just black-white segregation, but it acknowledges the fact that cities are made up of different racial and ethnic groups. And it posits what proportion of those of different communities would have to move within that metropolitan area across census tracts in order to achieve an even distribution of all the groups that live in that city, okay? And it ranges from 0% to everybody, okay? So generally, when you see places that are greater than 0.6, those are places are considered hyper-segregated. And you can see that in the United States, some of the most segregated places are in New England and in the Midwest, and then a couple places in the South. But there are also places that are segregated in the western part of the country. So we wanted to look at this issue of segregation initially a long time ago using US EPA's a great database that US EPA created modeling the distribution of ambient air toxics known as EPA's National Air Toxics Assessment. So this was our first attempt. It was the first attempt to look at the relationships between segregation and air quality. And so we looked at controlling for a lot of other area level factors that might explain levels of ambient air toxics. And this data set's beautiful because it models ambient air toxics for multiple air toxics at the census tract level. So you can link that with census tract level data on demographics when you're doing your ecological or cross-sectional studies. So what we saw was two things. This is looking for all the metropolitan areas. Each one of these lines represents a racial or ethnic group as defined by the U.S. Census. So this blue line are white residents, and the purple line are Latinos, green line are Asian Pacific Islanders, and the red line are African Americans. And you see, and then we stratified our cities by the level of multi-group dissimilarity index. So low levels to moderate segregation all the way to extreme segregation. And then this is looking at the estimated lifetime cancer risk associated with being exposed to multiple carcinogenic air toxics that are categorized by EPA as known, probable, or possible carcinogens. So we basically weighted them by their cancer toxicity. So after controlling for other area level factors that may explain the levels of these air pollutants, we found this persistent relationship where in most highly segregated places you saw more pronounced racial disparities in air toxics burdens. That may be not too surprising. It's one of those things where you get a grant to study a question that everybody probably knows the answer to. But the interesting thing that came up here was that overall for all these groups, including whites, you see that white residents, for example, are better off than their counterparts who are people of color in more segregated cities. But they're worse off than their white counterparts that live in less segregated cities, suggesting that there's something about segregation that degrades air quality for everybody. Now, for these air toxics come mostly from mobile source emissions, okay? So in more segregated places, it is not uncommon for people to have to drive more to get to basic things, their jobs, go to the store, basic services. And that can degrade the airshed for everybody. The other thing that people have written about, we didn't answer this in this study because we didn't have the data to answer it, but other studies have done this, is that in more unequal places, environmental regulations at a local scale tend to be less strict, particularly when there are deep power imbalances about land use decision making and where industries get sited. When there's more equal power, these kind of more undesirable sightings are less likely to happen anywhere, and sort of people in more unequal places think that they can site it somewhere else and they'll be okay, but it ends up degrading the airshed for everybody. Okay, and just to show that segregation is not a proxy for poverty level, so we did see still that racial disparity, but when you stratify your census tracts by poverty, you're not seeing that same kind of dose-response relationship. So there's something about that inequality metric that's different. Another thing that we looked at more recently last year, we got a hold of excellent modeled noise data because this is becoming of increasing interest to environmental health scientists. We don't have a lot of regulation of noise here in the States, but we're becoming more interested in terms of its health effects. It disrupts sleep. It has pretty significant mental health issues associated with it, hypertension, obesity, other kinds of things, and mental health. So we leveraged this layer of nighttime noise, and again, looking at, so this is a distribution of nighttime noise levels. We had other noise measures as well that I'm not going to show today. And so you can see kind of where the noise hotspots are. Not surprising, they're in cities. And we wanted to look at, again, sort of using a very similar analytical approach, looking at metropolitan statistical areas and looking at disparities in exposures to nighttime noise in urban block. This time we were looking at block groups, not census tracts. And again, we wanted to look, here is looking at the higher proportion of each racial and ethnic group. So this is for Asians, African Americans, whites, and Latinos. Again, as defined by the US Census. And you can see two things, that for most groups, as their proportion goes up, with the exception of whites, as their proportions go up, for whites, nighttime noise levels go down in the neighborhood, while for other groups, they tend to go up. But the other interesting thing that you see is if you stratify by segregation within these racial and ethnic groups, the least segregated cities very often have less stronger effects compared to places where they're in the red, where they're more segregated. So again, another environmental indicator where, in this case, you see this stronger kind of degradation of an environmental measure, in this case noise. Overall is worse for everybody, but still worse for communities of color than their white counterparts, even after accounting for poverty and other area level measures of neighborhoods that might explain these connections. The last thing we did, again, leveraging national data. In this case, we've become increasingly interested in this question of heat islands because of my lab's interest in climate change. And heat islands is also something that you can intervene on in a relatively short period of time in terms of thinking about climate change adaptation. So we looked at national land cover data that gives us information on tree canopy and impervious surface. And we were interested in looking at what are the risks in urban areas of living in a high heat island risk neighborhood. And we define that as a neighborhood or a block that didn't have a tree canopy and had over 50% of its aerial land cover as impervious surface. We did some sensitivity analysis in terms of changing those definitions, but these are the results, again, looking at segregation effects. And again, these color codes are the same. So these blue dots are for white residents, red dots are for African American residents, green is for Asians, and purple are for Latinos, and again, stratified by level of segregation. And so again, you see a persistent racial disparity related to segregation, which is not surprising. But you also see that heat island risks in general for everyone tends to be worse off in more segregated cities. So this is looking at the exposure issue, which we're interested in exposure assessment, particularly for things that we already know pretty well are bad for your health, because we feel like those can also be very informative on a broader scale and answering those equity questions and being able to inform decision making about how we might want to intervene. But we're also interested in what does this mean for health? Okay, as a scientist, we're particularly interested in this. So this gets at this other assertion around cumulative impacts in terms of socioeconomic status and stressors and the extent to which they might amplify any relationships we see between environmental hazard exposures and adverse health outcomes. So here is an example of a study that we did, and this study actually was done here, a very similar study in New England by Michelle Bell, where we were looking at the relationship between particulate matter and birth weight among California women who gave birth in a 10-year period between 96 and 2006. We were looking at different kinds of particulate matter. So this is PM10, PM2.5, and coarse PM. So we measured PM using air quality monitors in the state of California and apportioning exposures based on residential distance of each mother that was included in our birth cohort. And we had a lot of individual level information on the mothers that we were able to take into account, including access to prenatal care, socioeconomic status, and other things. And what we found was that particularly for PM2.5, which is the one that people are very concerned about because of its capacity to penetrate deeply in the lungs and cause adverse health effects, that we did see on average a 10-gram decrease in birth weight associated with a 10 microgram increase in PM2.5. And so we saw adverse effects for everyone, but we saw the strongest effects across all of these for African American mothers. So again, suggesting that certain groups, in this case, African American mothers, are much more vulnerable. Everyone is affected by PM2.5, but the strongest effects we were seeing in African American mothers. And Professor Bell's study she did it in Connecticut and Massachusetts, I believe, found she was comparing black and white mothers and saw very similar effects around the same range in the study that she did out here on PM2.5. Another study that's in prep right now, so this is kind of hot off the presses. California's in the midst of a big debate about what to do about the future of oil and gas extraction activities unlike places like Pennsylvania and Colorado, where natural gas extraction is a relatively new industry, the infrastructure for oil and gas development in California is quite old and has been around for a long time. But now some of these novel technologies, including hydraulic fracturing, are being introduced into some of this old infrastructure. And so there's a lot of interest in how this is playing out in California. There's been some suggestive studies around birth outcomes in states like Pennsylvania and Colorado. So we are currently looking at this in California. And we are looking at 3 air basins, which has most of the Southern California, the South Central Coast, and the San Joaquin Valley, where most of the oil and gas extraction activities happen. And so we are seeing, this is the overall effects for the risk of preterm birth associated with living within 1 mile of an active oil and gas well. And this is based on barrels of oil equivalent, so production volume of the wells. And the interesting thing is we're seeing some of the strongest effects in the sort of lower, this is compared to people who live near wells or no wells that have no production volume. So the strongest effects we're seeing actually are in neighborhoods that have sort of the lower average production volume compared to people that live near places that have higher levels of production volume, which is kind of interesting. And then we're also seeing stronger effects, for example, for different racial and ethnic groups. And this other group is making us scratch our head a little bit. We're trying to dig a little deeper, and particularly for Latinas. So, and African Americans. One of the reasons why we think we're seeing stronger effects in the lower production volume area is because some of the smaller producers tend to be less regulated. And on average, per well, they're producing less. So we think that this is characterized more by the smaller producers that are falling more under the regulatory radar screen. This is kind of what we're finding out with some of our conversations with the California Air Resources Board. Okay, the last thing is, actually I'm going to skip this. Okay, so what are the implications in terms of thinking about the cumulative impacts of environmental inequalities, and what do we do about it? Because I just showed you some highlights, but there's a lot of really good, like we could have a semester-long class about the science of this, and looking at other health outcomes. I tend to be interested in perinatal outcomes, which is the focus of a lot of what I do. But we're just starting to scratch the surface. Environmental justice advocates are pushing us in this direction. It's forcing us to become more interdisciplinary in our methods, and it's going to take a while for us to get our act together in terms of really sorting out what's going on. And yet, environmental justice communities are very eager to do something about this now, okay? And they are very supportive, and they often collaborate with scientists, but they don't want to wait around until we have definitive proof. And so there has been pressure on regulatory agencies, particularly in California, to really think about how can you develop mapping tools that can integrate place-level measures of environmental and social stressagens, if we want to call them that, that would highlight communities of regulatory concern, where then more work could be done in terms of regulatory tension, enforcement activities, more research, or allocation of resources. So several years ago, over 12 years ago, we were approached by the California Air Resources Board that said, we want to develop an environmental justice screening method. We have no idea how to do this, and we want you to develop something that's going to use publicly available data, that's going to have metrics that are transparent so that everyone from scientists to communities can understand what these maps mean and what goes into them. But it has to align with the research on environmental and social determinants of health. And we want to be able to apply it for a bunch of decision-making, land use decision-making, investments in enforcement activities, and community engagement. And they asked us to do it. And so we took them up on their challenge. We spent about 6 months looking at what publicly available data had statewide coverage. We spent a lot of time doing meetings with different kinds of stakeholders, community stakeholders, as well as industry stakeholders, other regulatory groups. We had advisory board made up of social scientists as well as environmental health scientists giving us advice. And we ended up with these kind of 5 big bins, if you will, of cumulative impact. One which was indicators, maps that we would develop of indicators of just being proximate to emission sources of concern. The second one that incorporated, for example, air quality data of the kind that I showed you today, pesticide use data, other kinds of things where we could actually get indicators of health risk and exposure, which is a little bit different than just being next to something that's emitting something. And then indicators of social and health vulnerability based on census data, and then also based on health data that's available in California, so rates of chronic disease or adverse birth outcomes, state data sources. We've just started to look at climate change vulnerability, looking at what's available statewide, and things like heat islands, temperature change, social isolation indicators. And then we're adding a drinking water layer, looking at both drinking water quality, but then also vulnerabilities of small systems, because if they have problems, they don't actually have the funds to fix them in terms of contamination problems. So here's an example. I'm not going to go through the methods of this, but this is a map of the San Francisco Bay Area, and these are the different maps for the different bins, scoring across a bunch of different indicators. And the red indicates places that are more of sort of higher on the quantile distribution for the region. So this is looking at proximity. This is looking at the health risk and exposure data combined in a score. And you can see like a lot of these very air quality centric, which is why a lot of this stuff is kind of blowing inland. Social and health vulnerability indicators based on census data. Climate change vulnerability based on land use, the heat island data that I showed you, as well as projected temperature changes. And then this is drinking water quality, which is pretty interesting because it's not that we live in a place with highly contaminated water, it's that there are a lot of small water systems that there's some concern about their capacity to deal with contamination issues should they arrive, because they have a smaller customer base. And then this is your sort of, you can combine these into a cumulative impact score to highlight places of regulatory concern based on all of these indicators. So you can peel it like an onion and look at the indicators that you're interested in, but then you can also kind of combine them to look at it. And you can score them based on the region, quantile distributions in the region, or statewide. So after we develop this, we also, because we want communities to actually understand and appreciate, and trust this, because there's going to be decision making on this, we embarked upon a ground truthing exercise throughout the state with communities. We worked with communities to monitor areas of concern and highlight sources that we may not find. We talked about some of the shortcomings of administrative data sources. So this was quite successful, and the question is now, so what the heck did you do with it? Well, eventually, the state of California, because of our project, was required to develop its own system. So the system that we developed became a huge input into what is now known as CalEnviroScreen, which you can look at online, and it keeps getting updated. So we basically kind of showed the way for Cal EPA on how to do this. And the beauty of this now is these are the indicators that they're using, and they've added some and taken some of the ones that we used out. It's a good system. We provided them with a lot of data to do this. These maps are now being used to make decisions. California has a climate change law. It has a cap and trade system. Industries have to pay to emit greenhouse gases, something they used to be able to do for free. And as a result of that program, legislation was passed to create a greenhouse gas reduction fund, where a portion of the revenue generated from cap and trade has to be invested in programs that benefit environmental justice communities and vulnerable groups, about 35%, and 20% has to be invested in those neighborhoods directly. So those maps that I showed you and CalEnviroScreen is being used to figure out where those investments should be going. And so this program has been in effect for quite a while. These programs support everything from clean transportation, housing, forestry projects, all kinds of projects. And that is a whole lecture in itself, how well and challenging it is to implement. But you can go online and see where these investments were last year, which is kind of amazing. And the last thing I want to say in terms of climate change policy is we can, now that California has passed a climate change policy, instead of, as environmental justice researchers, documenting the problem, like who bears the burden, who's getting ill, we can actually start trying to document some successes. So this is an example that was done in my lab by a wonderful postdoctoral fellow, Joan Casey, where 10 power plants closed in a period of 10 years, and 2 of them were coal-fired power plants. And so we took advantage of the fact that this was a natural experiment, and they closed in part because they saw the writing on the wall because of California's climate change law. It was going to become clear that these plants were no longer economical to run. So we wanted to ask ourselves, what happened when those plants closed? Did we see an immediate health effect? And the answer is yes, we did. We saw that we looked at the risk, what happened with preterm birth rates a year after these plants closed. And we were able to show, using a difference in difference analytical approach, that plant closures were associated with a 2% reduction in preterm birth rates within a year after the plants closed. So these are the overall estimates, and the red is for people who lived within 5 kilometers of the plant, and the orange is people who lived within 5 to 10 kilometers. And then this is different type of preterm birth, so we saw the strongest effect for preterm birth between 32 and less than 37 weeks. And then the other thing is we stratified by race and ethnicity. And we saw slightly stronger effects for Asian and black mothers. So 2% is actually a lot. Like if you developed a drug that reduced preterm birth by 2%, it would be considered a blockbuster, just to give you some context. So the change was basically from a 7% rate to a 5.1% preterm birth rate in the post-plant retirement period. Okay, so just to conclude, I think as we as scientists kind of grapple with how to do a better job of understanding social determinants of environmental health disparities and really get at the questions that environmental justice communities want us to elucidate better, that I think that there's a lot to be said for having some form of community engagement as you go along. Sometimes that means really deep community-based participatory research. Sometimes it means just collaborating with them in the regulatory process when you're developing tools for decision-making like I just showed you today. And the goal really is to move us from this continuum that I like to show of, those of us in NIH who get NIH funding are always being told we need to translate our research results. And I would argue that when you're doing this community engaged work, you want to actually move from translational research to actually transformational research, where you're actually seeing a true policy impact, where you can actually not only see changes in policy and investments to address these perennial EJ problems, but the changes that you're seeing, you can actually start to document the health benefits in the short term, which in this case is building a very much more diverse constituency to support climate change policy in the state. And so with that, I will end. Thank you. Questions? Yeah.
Thinking about the Bay Area, there's a lot of places to be with the way development is really ratcheted up there that have really diverse neighborhoods with all this influx with really high median incomes too, the way that sort of a few people making 6 figures can bump up the median income for an entire neighborhood.
Yeah.
I'm wondering how that sort of really small scale inequality can be captured by the sort of metrics you're describing, right?
Yeah. So you're talking about gentrification at these micro scales. Yeah. Yeah, so with the metrics that I showed today, does not get at that. There's another indicator that we're using, which is index of concentration at the extremes, which is very nice. It gets kind of at that more micro level of neighborhood level of inequality, the extent to which wealth and or income is concentrated in a few hands just within a neighborhood as opposed to across a metropolitan area. In our, we did another temporal green space study, which I didn't show, and we did see effects associated with that income concentration at the extremes metric at the block group level. So that's another way to get at this inequity. And I think you need to look sort of both at the broader context at the MSA-wide level, because I think that gets at kind of power differentials where land use decision making is getting made at that level. But then again, at the neighborhood level is extremely important. And you have to get beyond sort of compositional measures like percent people of color and things like that. Yeah.
Thank you for all the great work that you do in pushing forward environmental justice into environmental policy in California in particular. If you could talk a little bit more about the contentious nature or the politics around creating institutionalizing some of these scientific tools, such as the CalEnviroScreen, or some of the important work that you've done around documenting the impact of cap and trade.
Okay. That was the lecture I was thinking about giving. Yeah, so I glossed over that due to time, but you know, California is a beacon of hope in the sense that we have a climate change policy that we're implementing, but it has not been without controversy. And one of the biggest fights in California was the fact that the decision was made that the strategy for addressing greenhouse gases in big industry was going to be through cap and trade, and EJ advocates were strongly opposed to that. Yeah, because they felt very strongly that a lot of the regulated industries are disproportionately located in their neighborhoods, and they were worried that a cap and trade program would enable those industries to buy their way out of the problem, and instead of reducing locally and those communities having, because when you reduce greenhouse gases, you're also reducing levels of other harmful pollutants that affect health right away. And so they felt like that was going to be a foregone opportunity to address these perennial issues that communities have been struggling about for a long time. So they lost that battle. We ended up with a cap and trade program. But environmental justice groups came together, and actually they were the ones that pushed through that legislation to create the Greenhouse Gas Reduction Fund, which requires that a significant portion of those monies are invested in programs that benefit environmental justice communities and be invested in their neighborhoods directly. There are other streams and pots of money that are also allocated through our climate change policies. Michael's been writing about it forever, so so I would say that it has been a really contentious process, but there's always been kind of a shift, and EJ advocates are still, I think, have a seat at the table and have created, I think, leveraged creative solutions even in the face of certain losses like around cap and trade. But it's still, yeah. I don't know if you have anything you want to add, since this is your area.
I guess what I'm also interested in, how do you, as a scientist, how do you react towards industry attacks against your research? If you can explain, tell us a little bit more about that.
How do I address industry attacks on my research?
Yes, or they contest the methods and the findings.
A lot of ways. I mean, one of which is I'm very open and trying to be as open and transparent about our methods as possible. I think it's really great that in a lot of journals you're required now to post your data so that people can try and replicate your results. So if they want to poke holes in my methods, I'm like, here's the data, go for it. And then hopefully you too will document what you did just as well as I did, So I think that that whole data judo thing can be effective. And I think the other reality though is that if they don't like your results, they are going to still perennially attack for any uncertainties that you come clean with, which there always are. I have been on the Jump Science Hall of Fame in the past, which is a little bit of a badge of honor. And then also being in close contact with the regulatory agencies themselves about what you're doing, they may not always appreciate. So, for example, the Air Resources Board loved the coal plant study, because that was like great. That's a happy story for them, because those plants closed, and look, it improved health. But then they weren't happy about another study that we did that showed that the cap and trade program, the performance of industry hadn't been as good. So, they weren't too happy about us when they talked to reporters.
Thank you.
Yeah.
I wonder if you could speak to just a little bit how, thanks, mainstream science constrains what you're doing. So going the other way from regulatory agencies, from industry, just the idea that as soon as you deal with the kind of issues you're dealing with, you've got multi-causality, and so your inference is necessarily weaker. And so proposal review panels just don't fund that work and just go for things which are much, much cleaner to
Yeah.
work, but potentially much less relevant.
Yeah, that's a great question. So, this kind of work is not work that I get funding from NIH. I get funding from NIH for my more traditional work, like my pregnancy cohort study. NIH often, for example, kind of wants you to have the answer to the question that you're going to answer. They want you to have proof that you're going to get that answer almost, so you need a lot of preliminary data, for example. So those kinds of funding agencies are not really great outlets for this kind of scientific work. We're fortunate in California that we have other funding agencies, like the California Air Resources Board has a research program that has a review panel, and they funded the Children's Health Study. They seeded the Children's Health Study at USC. They've seeded a lot of our work. Then we were able to leverage NIH funding once we had data, which was very useful. But one of their criteria for their funding, in addition to being great science, is it has to be relevant to the policy concerns of the agency, because they want that science to help them be good decision makers. So, in all honesty, some of this stuff, a lot of the stuff that I do is funded by NIH, but it's much more traditional, individual level kind of epidemiological studies or lab-based science. And you have to look to other sources, foundations and state funders to fund this other stuff. It's more risky. Yeah.
I think all of us are concerned with how you talk to groups where your opinion, your data in your case, don't agree with their worldview.
Yeah.
So I've tried to find one, but you can pick another one. One of them would be to go into the white, hyper-segregated communities and let them know that they would actually be better off in a more integrated community. So that would be an example where you would be talking to people who would tend to say, we don't want to hear it, or whatever. So that's just an example, but I'm wondering if you could tell us a little bit about what it's like when you do go into a group at the community response level where you're giving them a message that you have a feeling they don't want to hear.
Yeah, that's a great question. So, yeah, we talk about this a lot. So one of my things is I actually don't approach communities for my research. I generally have these relationships have started up because we've gotten approached by environmental justice organizations or community groups who have a question. So often it starts out with, here's an example. I'm working on a study of women firefighters in San Francisco. Women firefighters work very hard to desegregate the fire department. Now the fire chief is a woman. They have been in the fire department now for a long time, and they are very worried about what they perceive to be elevated breast cancer rates in their ranks, and they are sure that it's associated with their job. So I got a call, and they were like, I'm from United Fire Service Women. We want to do a study on how our job causes breast cancer. That was how we started out the conversation. So I was like, well, I'm very happy to talk to you. So we had a long-term conversation, and we started having a conversation about the fact that it may seem like there are lots of breast cancer around you, but it still may not actually be true that it's elevated. And two, even if there is something going on at work, the numbers of women in the in the fire service is too low to even see a signal, even if there were something there. So, and then the third question is, they were like, okay, so if we can't do a health study, what can we do? And so what we ended up doing is an exposure study. And we're doing a biomonitoring study, and we are comparing female firefighters with office workers who are not first responders, and we're biomonitoring them for chemicals that are associated with different kinds of things that are also known to be breast carcinogens. And we can't say anything about breast cancer, but we might be able to see something about whether or not they have higher levels of these compounds that have been shown in toxicological studies to be mammary carcinogen. That's as good as we can get. And we've talked about the risk. I said you have to be willing to face the risk that the data may show that the office workers have higher levels of some of these compounds that you're worried about. We don't know what we're going to find. No one's ever done this study before. So can you live with that? Because I have to publish my results regardless of what they find. And are you willing to take this risk? That's what, and you have to have that conversation before you write the grant, before you design the study, and have all your cards on the table. And I've had some groups say no, in which case we don't go forward. We just don't do the work. But yeah, you have to have that I think you have to have that conversation before you even do the study. Yeah.
How do you incorporate cumulative impacts in regulatory decision making? I mean, oftentimes, a source may be below a threshold and therefore gets a more lenient regulatory treatment, even if it has a cumulative impact.
Well, so what Cal EPA is trying to do now more, for example, the Department of Toxic Substances Control that regulates about 82 waste facilities in the state, is traditionally they treated the facility as like isolated, and now they have to take more into account the context of the other types of facilities that are there, industries that are there that are also having environmental impacts. So, when they're talking about how do you take into account cumulative impacts, it's also about taking into account the makeup of the community itself. What are some of the underlying prevalence of certain kinds of health conditions that could be associated with environmental exposures, not necessarily related to that facility, but just in general? And then what are the other kinds of environmental hazards that are around there? And then when you're regulating these industries and reissuing their permit, taking those issues into consideration and having these industries think more collectively about what's going on in the neighborhoods.
We are at 1 o'clock. Thank you very much.